Hello everyone and welcome back to the channel. In the last episode we had already discussed what is serverless and why we need serverless computing and what it helps us to achieve, and we had a short introduction on the topic. So if you haven't watched that video, then please do so. It's on the I button above on the right side, and here we have our AWS serverless roadmap and we will cover them one by one. And today we're going to discuss the actual serverless computational service. And let's start off with AWS Lambda and let's understand what it has to offer. So if you're ready, let's begin. So in today's session, we will be discussing about what is AWS Lambda, what is the need for using AWS Lambda, and we'll also see the differences between AWS EC2 and AWS Lambda. We will check out some of the trigger points that we have for AWS Lambda, that is the AWS Lambda trigger points, and we'll also see some of the features for AWS Lambda, and we'll also have some mathematical calculations that we will do for the pricing model that we have for AWS Lambda. And also in the next session, I'll also cover a very important topic, that is basically your concurrency models, where we'll cover both reserved and provisioned, and then at the end we will discuss about architectures and designs for AWS Lambda. Okay, so as we are going to talk about serverless compute and deployment, let's check this real-time example. So your boss in a meeting came up with a new requirement where he wants you to deploy an application, and he said, "Hi, host an application which will be used as a simple reporting API service for our customer data, and let me know once it's done." And you were fine with that. You said, "Sure boss, I will work on that as soon as possible and will update you once the service is up and running." So you went ahead and wrote your API code, and your first thought was to deploy it on an EC2 instance because you have been doing it for a long time while hosting applications. And to host it on EC2, you had to go through these steps. So you had to choose the VPC, then you had to choose the AMI for the purpose, choose the right processing unit, choose subnets to maintain high availability, then choose the storage, and then attach the security group, and ultimately you had to deploy the code that you have. Then you took a pause and you realized that you still have a lot to do. So you went ahead and created the launch templates. You then created the auto scaling groups. Then for the load balancers, you created the ALB, and then for the storage, you created the deployment for the database. And finally, you succeeded in creating the deployment. Finally, you came up to your boss and you were happy to share this information. "Hi boss, we are done. I have hosted the application and we can make use of it." And you said you had deployed it with an EC2 instance with auto scaling. Your boss went ahead and rejected this, saying, "This is not feasible. It's just a simple report generator. Do you want us to spend this amount of time in future as well, managing these servers for a single service, which will be used in short spans?" There was nothing wrong with the product and the API service. The users would still be able to make use of the service, but the thing that would get affected is the efficiency of the platform and the infrastructure maintenance. The amount of time that we would spend in maintaining the instances and the deployments for a small or simple one-directional API service would be fairly laborious, which would not be a feasible option in the longer run due to the operational overheads. And that's where AWS Lambda came into the picture. So you went ahead and switched things around by moving on with the serverless approach. You started off by deploying your code, which is an API service written in Python, by creating a Lambda function, by providing the required memory for its processing. For the report files, you attached an Amazon S3 bucket where you planned to store your report files. For table entries and the inventory and the user data, you moved ahead and attached a DynamoDB, which is a serverless NoSQL database. And for your API trigger point, you went with the reverse proxy service API gateway, which we will be discussing in the upcoming sessions as well. For now, just remember that API gateway is a service provided by AWS, which helps us to create an entry point for the backend services and which sits between your clients and the services you host. So now the users are happy and they are able to connect to the API, and your boss surely appreciates the design. But you might ask me, what did we achieve by switching our application hosting to AWS Lambda, which was already hosted on EC2 instances? and why we moved to a serverless architecture. That is the reason we are here. So let's see what we can achieve with EC2 and what makes it different than Lambda, and why we went ahead of using Lambda and not EC2. So when it comes to EC2, the basic idea is to create a VM, that is the virtual machine, so that you can use it anytime that you want. But the problem is that it has to be running all the times, even if there is no traffic at all. But here we are not trying to defame EC2 instances, because EC2 is powerful in its own rights. And most of all, let's check these points. If you wish to go in depth, you can read more about this in the documentation as well. So we mostly recommend using EC2 instances if you want to host a complex multi-purpose website, or if you are hosting and testing with multi-purpose processing powers for various use cases, or when you need consistent high performance computing, or when you have the need to create pre-configured images or customized AMIs. On the other hand, Lambda is a very short and simple multi-utility serverless service, but without a doubt, it's a very powerful one as well. So when we compare it with EC2, in AWS Lambda, we don't have to launch any virtual machines to host our code. And that would be the most basic difference, as its rightful name comes from being a serverless computing powerhouse. But for now, let's talk about some of the pointers here as well. If you want to host short compute time modules, or if we want to provide a function as a service using AWS Lambda functions, of course, or if we want to provide a compute power for simple task automation, or if you want to have a provision for real-time log analysis, and henceforth. So these are a few differences that make AWS Lambda very useful when it comes to compute optimization. I know you guys might be thinking of so many other reasons, but don't worry, till the end of this session we would have already covered them as well. But I felt it was the right decision for me to clear some of them right now. Now let's come back to the actual topic and let's discuss at length about AWS Lambda. So as per AWS Lambda lets you run code without provisioning or managing service, and you pay only for the compute time you consume. So here you don't have the need to launch virtual machines and keep them running all the time, and you pay for the compute time only. I hope you remember the previous session we already discussed about serverless and why we associate the use case with this term called serverless. If you haven't, then I would request you to please check the video out. Link is in the I button above on the top right corner. As I've already mentioned before, with serverless you need to bring your code or application, and you don't have to worry about the application hosting, and you will be provided with the computational resources that you need to create a productive application with obviously a high availability and the power that it needs to serve its consumers' requests. So when I say AWS Lambda lets you run code without provisioning or managing servers, and you pay only for the compute time you consume, what it means is that you can run code for virtually any type of application or backend service, and you don't need any administration of these servers. You have to just write the code that you want on the Lambda editor, or if you want, you can upload your code to AWS Lambda, and Lambda will take care of everything required, or what we rightly call as resource provisioning, to run and scale the code that you have, and in turn it will also provide high availability. And the best part about this is that AWS Lambda, you can set up your code to automatically trigger from other AWS services or call it directly from any mobile or web application. That gives you the power to get the results from anywhere you want. So there are a few important features of AWS Lambda that we have to discuss. First off is no servers to manage, and AWS Lambda automatically runs your code without requiring you to provision or manage servers. I think this is quite evident now that you don't need to create or provision or manage any servers to run your code, and you can just post your code on the AWS Lambda and run them using any trigger point. The second one is continuous scaling. So for continuous scaling, AWS Lambda automatically scales your applications by running code in response to the trigger. So let's suppose you have a lot of users using your service, and in that case your code can run in parallel and each trigger will be processed individually. That's a very big thing. The trigger means an API call or execution, like for example you send a GET request or a POST request to perform a call using an HTTP request, and the scaling will be done automatically based on the size of the workload. The third one is sub-second metering. So sub-second metering means like charging you for a unit of work or operation. So with AWS Lambda, you are charged for every 100 millisecond your code executes and the number of times your code is triggered. So you are charged for the unit of work that you perform. The last one is consistent performance. So whenever we host the service, we try and estimate the amount of processing power that it might need, isn't it? And based on which we provide the resource. Here with AWS Lambda, you can optimize your code execution time by choosing the right memory size for your function. And you also get the option for provision concurrency to keep the response time within double-digit milliseconds. Don't worry, we will discuss about this in a short time. So now let's check the visualization here. So here it's a very simplified way to look at the workflow with AWS Lambda. First off, you write the code that can be your service API, or you can upload it to AWS Lambda. And then you create a trigger point that kicks off the Lambda code that you have and the code execution using a static website that is hosted on the AWS S3 or any trigger point that you have, which in turn triggers the function that's hosted or written into using AWS Lambda. And upon execution, you get the result back and you are charged only for the compute time, or what we can also phrase it as the duration of time it takes to execute the code. So you write the code, upload it to Lambda, then execute your code with a trigger point and get charged for the compute time. I know you might be thinking I'm speaking a lot about trigger points and so on, and what are these trigger points? So trigger points are the ways you can call your Lambda code. So don't worry, that's what we'll be discussing next. I hope this was clear. Let's move on. So there are several ways with which you can trigger AWS Lambda, and let's discuss them one by one. So I'm sure you are aware of what is the difference between synchronous and asynchronous calls. I hope you are. So the first one is synchronous invokes. So here your function executes immediately when you perform the Lambda invoke API call. So it's a synchronous call where you don't have to wait or poll for the response to come at a later stage of time. Okay, so among them we have services with which we can trigger AWS Lambda. So here we have Elastic Load Balancers, or Amazon Cognito, Amazon Lex, Amazon Alexa, Amazon API Gateway, Amazon CloudFront, that is Lambda at the edge, and Amazon Kinesis Data Firehose. Okay, so next off we have for asynchronous invokes. So here it places the invoke requests in AWS service queues and processes these requests as they arrive. So we have services with which we can trigger AWS Lambda for asynchronous invokes. So they are AWS Simple Storage Service, or AWS S3, or Amazon Simple Notification Service, or Amazon Simple Email Service, and AWS CloudFormation, AWS CloudWatch Logs, AWS CloudWatch Events, AWS Code Commit, and AWS Config. And apart from these two, we have another one which is poll based invoke. Here Lambda will poll the following services on your behalf, retrieve record, and invoke your functions. So here we have Amazon Kinesis, Amazon SQS, and Amazon DynamoDB Stream. And let's check the language support that we have for AWS Lambda. It's a very good thing that we have a lot of languages that we can use to write AWS functions. So it starts off with Java. You can have support for Golang, a PowerShell, a Node.js, C#, Python, and Ruby code as well. And for the relational database, you will be given the support of RDS proxy, where you can make use of MySQL and Aurora databases. Okay, so I hope this was clear. Let's move on. So now let's understand the three trigger points that we already discussed carefully one by one. So the first one is the synchronous push, where we use the API gateway and trigger an API that is product/data, and it executes the code present at Lambda. So this is a synchronous call or a synchronous push. Okay, so when you summon the API by sending an HTTP request, you get the response, and that's how the synchronous push works. So the second one is an asynchronous event, where you can push the request event to SNS or SQS messages to modify or perform operations on the website hosted at S3 or the file hosted at S3, and each of these messages are pushed to an event, and these requests will be executed when it is received by AWS Lambda. And the same concept is followed the way we saw with SQS. Okay, so the third one is poll based, where you can see we have the Lambda polling for the changes from the Kinesis data streams, which is stored in the AWS DynamoDB, and once it receives the data, it will be processed by the AWS Lambda. So as you can see, we have the AWS Lambda polling the data streams from the Kinesis, and which in turn pulls it from the DynamoDB, and based on that, once it receives the data, it actually performs the operation. I hope it was clear. Let's move on. So now let's check some of the features of AWS Lambda, and these points might seem to be pretty lengthy, but they are very important. Okay, so you can create new backend services for your application that are triggered on demand using the API or the Lambda API or the custom API endpoints built using Amazon API Gateway, as we already discussed. And Lambda natively supports Java, Go, PowerShell, Node.js, C Hash, Python and Ruby code, and provides a runtime API. And Lambda manages all the infrastructure to run your code on highly available fault-tolerant infrastructures. That's a very good point for people who just want to run the code and deploy services without taking the headache of managing servers. And Lambda has built-in fault tolerance, so you will never realize if there is any outage. And AWS Lambda invokes your code only when needed and automatically scales to support the rate of incoming requests without requiring you to configure anything. Here with Lambda, you don't need to host your application with auto-scaling groups with CloudWatch metrics to determine the amount of load to make it scalable. And for people who are looking for any support for relational databases, here in AWS Lambda, RDS Proxy offers support for MySQL and Aurora. You can use RDS Proxy for your serverless applications. Next, we have the provision to use AWS EFS with the Amazon Elastic File System for AWS Lambda, and you can securely read, write, and persist large volumes of data at low latency at any time or at any scale. And with AWS Lambda at Edge, AWS Lambda can run your code across locations globally in response to Amazon CloudFront events. This topic we'll be discussing in length in the next part of AWS Lambda. For now, you just need to remember that with AWS Lambda at Edge, you can run your code across regions and locations with CloudFront. And you can also use step functions along with Lambda, and you can build stateful long-running processes for applications and backends. And what step function helps us is that it helps us to create event-driven workflows by creating a sequence of AWS Lambda functions and AWS services that can fit into a business process workflow. And when it comes to security, AWS Lambda allows your code to securely access other AWS services through its built-in AWS SDK and integration with the AWS Identity and Access Management, that's our IAM. So if suppose you want to access CloudWatch or S3 or any other service from your Lambda code, you can create an IAM policy for Lambda to allow access for these services. When it comes to pricing, with AWS Lambda, you pay for the execution duration rather than by the server unit. So what it means is that you don't pay for the servers because you don't host them. Then what will you be charged for? Obviously, it will be charged for the requests you made and the server usage per unit. Okay, here the benefit and equally important thing is remember that when you host your code in Lambda, you choose the amount of memory you want to allocate to your function, and AWS Lambda allocates proportional CPU power, network bandwidth, and disk I/O. So if you increase the memory, it will increase the processing power proportionately for your computation, and you will pay more as well. And that's what we will discuss next. So with AWS Lambda, it counts a request each time it starts executing in response to event notification, including test invokes from the console. And if you talk about the duration of compute, the duration is calculated from the time your code begins executing until it returns the result or otherwise terminates the request, which is rounded up to the nearest 100 millisecond. I won't explain you rounding up values in terms of maths, but it's simple. For example, if you have a value of 145, when rounding up to nearest 100, it comes closer to 100 than 200, isn't it? And 180, if you have the value 180, it moves closer to 200 than 100. So if you use it for 180 milliseconds, you will be charged for 200 milliseconds, which is the value that we have when we round it up to the nearest 100 milliseconds. Okay, so this was a simple mathematical calculation that you can also do. But here we are going to discuss about the pricing for AWS Lambda. So the price that you have will be charged on you depending on the amount of memory that you allocate for your function and the proportionate CPU power. As I've already told you, when you host your code on AWS Lambda, you choose the amount of memory that you want to allocate to your function, and AWS Lambda allocates proportionate CPU power, network bandwidth, and disk I/O. So if you increase the memory, it will increase the processing power proportionately for your consumption. And there is a very good thing for the free tier people here. So with AWS Lambda free tier usage, it includes 1 million free requests per month and 400,000 GB seconds of compute time per month. Here you might feel what kind of unit of measurement is GB seconds, and honestly it's a bit confusing as well, isn't it? But listen to me very carefully. So I've told you that you have to allocate memory to execute your code, and that can be like around like 500 MB or 1 GB or 2 GB. So GB second means the number of seconds of computing you have done multiplied by the number of GB of memory that compute allocates. So let's suppose you allocated 1 GB and it runs for 5 seconds. Then it's calculated as 5 GB seconds. Okay, and for the request we have $0.20 per 1 million request. So it's like 15 rupees per 10 lakh requests. And duration of 0.000016667 for every GB second. So it's a very menial charge, but on a longer run, if you have millions of users, it will account to a very huge price. And just like banks, we have saving plans here that provide a flexible pricing model that offer low prices on EC2, Lambda and Fargate usage. So we have two here. So the compute saving plan provides the most flexibility and helps us to reduce our cost for up to 66%. And for EC2 instance saving plans, so here EC2 instance saving plans provide the lowest price offering and the savings up to 72% in exchange for commitment to usage of individual instances, families in the region. Okay, for example, M5 usage in North Virginia. So these are the instances actually that will be used. Okay, so now that we have done the theoretical analysis of what is the pricing model, let's see a basic example for calculating the price of AWS Lambda usage. So let's take an example for AWS pricing and let's take a case study. So you created a Lambda function and let's suppose you allocated 512 MB of memory to your function and executed it 3 million times in 1 month. And it ran for 1 second each time. Your charges would be calculated as follows. So here I am not trying to insinuate that you ran 3 million times equally divided across 30 days, but it's relative, isn't it? I hope you get the point. The first thing that we need to calculate is monthly compute charges. So the monthly compute charge price is 0.000, that's a 401667 per GB seconds, and the free tier provides 400,000 GB seconds. Remember, I'm not saying GB seconds as GB per seconds. I'm telling you that is GB seconds. So it's a multiplication. GB per second would be a division. Okay. So the total compute seconds is equal to 3 million requests multiplied by 1 second. That is 3 million seconds. So the total compute time that we have in seconds is 3 million times that it ran with 1 second each. So it is 3 million seconds. And the total compute GB second is basically your 3 million seconds multiplied by 512 MB because you allocated 512 MB of memory to your function by 1024 just to convert this into GB, 1.5 million GB seconds. So now the monthly billable compute GB second is your total compute minus free tier compute. Okay, so the total compute that we have is 1.5 million GB seconds minus the 400,000 free tier GBs that you get. Okay, so it comes around 1.1 million GB seconds. So now the monthly compute charges will be 1.1 million into the duration amount that we are charged for, that is your 0.401667 dollars. So it will come around 18.34. So this is the monthly compute charges. So how much you are asked to pay for the monthly computation. So this is the computation charge. Now there is the monthly request charge. Okay, so the monthly request charge price is 0.20 per 1 million requests, and the free tier actually provides 1 million requests per month. Okay, so this one, 1 million free requests per month. Okay, so the total request minus free tier request is monthly billable request. So the 3 million that you get, that you have assigned already, the 3 million time. So as it executed for 3 million times in 1 month, so the 3 million requests minus the 1 million free tier requests, so you get 2 monthly billable requests. So this is the actual spending that you have. So monthly request charges will be 2 million into 0.2 per million, so it is 0.40. So that is the request count. Now the total monthly charges will be monthly compute charges plus monthly request charges. So the total charges is 18.34 plus 0.40, that is 18.74. So if you allocated 512 MB of memory to your function, executed it for 3 million times in a month and ran it for 1 second each time, you would be charged for 18.74. And this is actually relative to a particular region. So if you change the region, you will be charged in a different amount. So now that we have discussed the pricing model, let's design some applications. So here is a simple architecture for you using AWS Lambda that you can also implement. So the requirement for this product or the project is that we want to create a mobile application that helps you create and publish posts to your application, and that post should be published across all your friends list. Okay, don't think it is Facebook or something. We are completely reinventing the wheel by doing something new. Okay, so what we have to do here is we have to create the mobile application, and for the API REST service we use API gateway to make API calls to the backend service here, which helps us to execute our code by acting as a trigger point, and also helps us to authenticate and process API requests. And to execute our code, we are using AWS Lambda to write our API code, and whose task is to find out the list of friends you have. So we are using the code execution point or the trigger point as the API gateway, and to execute the code, the function that we use is AWS Lambda. So that was the whole purpose of using Lambda here. And that can be multiple messages that could be posted on the account. So for this, we are using AWS SNS to publish the messages onto the message broker so that it can be sent to all the users who are part of your friends list. And you can simply write your code that fetches the list of friends that you have using the AWS Lambda function rather than deploying and managing EC2 instances. So this is a pretty simple example or architecture of using AWS Lambda. So you write the application and you create a trigger point using API gateway, and that actually triggers your AWS Lambda functions, and whatever output or social media message that you have gets published using the AWS SNS that actually propagates across your friends list in the media app, social media app. And as all of you wanted me to talk more about real-time examples and models, let's check one more design for a simple application using AWS Lambda. So the requirement of the product or the project is that you need to create a web application that could be accessed via desktop and also could be used in mobile application, which helps the user to get the stats of the cricketers and the teams for the users, which would be geolocation based. So let's suppose a user in London would be shown more about the cricketers of England cricket team, and similarly for a person staying in India, it would be shown for the players of Indian cricket team, obviously. So here what we have done is we have put our HTML static code in AWS S3 bucket, and when the application needs to communicate with the backend, it can send an API call to the API gateway. The data of the cricketers and teams are stored in the Dynamo database, and the logic for fetching the data as per the country or the location is hosted on the AWS Lambda function. And AWS Lambda fetches the data for the cricketers and the team by communicating the same with the AWS Dynamo DB, and it passes to the website to host dynamic content based on the user's location. So here what happens is whenever the user is in London or any part of the world, by using the API gateways, we are able to calculate or we are able to trigger the AWS Lambda function, which fetches information for the cricketers and the players which are close to that particular region, and that is what we are able to show to the user. And that actually gives us a sense of hosting dynamic website by using our front-end static code. So that's all for the today's session of AWS Lambda, and we are going to continue with this in the next part that we have for AWS Lambda, where we are going to discuss about provision concurrency and reserved concurrency. So don't miss out on that, and later on we'll follow that up with AWS Lambda at Edge. So that's it for the part 1 of AWS Lambda, and I'll meet you in the next session. So it's Pytholic signing off.